Hi students, today we are going to see into 20 EC 6910 Professional Ethics, Unit 3, Engineering Projects and Expected Traits. So this unit will be regarding how the engineers should handle the engineering projects so that it should be safe to all the community of people, and what are all the expected traits. Traits, it is nothing but a quality that forms part of the engineer's character or personality. So what should be the engineer's character or personality, and what are all the projects they are going to handle, and how the project should be handled in an effective way so that it will be safe to people. So this is about Unit 3, Engineering Projects and Expected Traits. So this is the syllabus: engineering as experimentation, engineers as responsible experimenters, codes of ethics, research ethics, balanced outlook on law, collegiality and loyalty, respect for authority in industry, collective bargaining, confidentiality, conflicts of interest and conflicting interest. So thus we are going to look into the introduction part. So we have seen about the theories of ethics in previous lectures. Here we are going to see about the roles and responsibilities of engineers. In engineering, experimental process plays vital role. It's very important role because it may take some of the people's life, it may cause some danger, it may lead to loss of their body parts or loss of many economical values. So engineering field is a risky one. All technology products may present some dangers. It makes engineering as risky. Already developed products may produce danger in later years. See about how engineers can reduce the chance of risk. So for example, to be in a precise understanding, you might have learned about Titanic ship. It is the largest ship made at the time, can accommodate with a crew of 3,500 passengers. So what happened on April 1912 is engineers told that it could float even if 4 compartments are flooded. Started with 2,227 passengers, captains sailed the ship at the area, surrounded by icebergs. There isn't enough lifeboats for all the 2,227 passengers. Lifeboats were available only for 825 persons. So obviously what happened? 1,522 persons died. This shows the technological complacency. Wherever great risk to human life is involved, a precautionary safe measurement should be necessary. So with this, we enter into the first topic of Unit 3, Engineer as Social Experimentation. Every product must undergo various experimentations, not only in laboratory but also in view of general public. Because the product reaches the public are the persons who are going to judge the product. They'll be using the product, they'll be providing some feedbacks. The feedbacks may be positive or negative. So based on the feedback, we have to change the quality of the product, change the quality of the service. Tests can be made at different levels. The test may be at preliminary test, material test or after production test. With the feedback of test, further modifications can be done. So engineering project is always an experiment. So similarities to standard experiments. Any engineering project is put into practice with practical ignorance because while designing a model, there may be several uncertainties. The engineers don't have all necessary things in advance. Theoretical examining and laboratory testing makes the product into quality one. So in real, engineers have a partial knowledge about how the product is going to work. So the final outcomes are uncertain. Knowledge possessed about the products are initial and end stages, useful for current and future products. Periodic observations have to be done. Test of products should be efficient. Cost effectiveness, environmental impact shouldn't be there. Utility to society is to be monitored. The uncertainties are model used for design calculations, exact characteristics of material used, constancies of materials used for processing and fabrication, about the nature of pressure the product will encounter. The knowledge possessed about the products at initial and end stages useful for current and future products. So that means that knowledge about that product should be gained by the engineers at the initial and end stages, so that from starting itself we are going to monitor the product's quality. Periodical observations can be done through it, and test of products will be efficiently done, so that after completion we will be able to judge the quality of the product. So that if we done the quality testing in initial stage, we can make changes in initial itself, so that the loss of the product can be under control. So after testing, if we find any discrepancies, that can be altered in further production process. Learning from the past. So engineers should know about the results of their own and others' product. Lack of communication, fear of law, negligence may cause the continuation of past mistakes. For example, Titanic, due to insufficient lifeboats, same disaster took place in the Arctic some years before. So, if that incident was kept in mind and some rectifications are done by the Titanic engineer, then Titanic disaster might not happened at that time period. So we have to learn from the past. Some other incidents are mentioned here. The nuclear reactor accident at 3 Milestone on March 1979 due to lack of information about opening and closing of valves. Disaster due to same thing happened years before. So disaster of Tetron Dam in Los Angeles was due to rapid flow of water due to sudden breakdown. The builders doesn't consider that in the case of Fontenelle Dam, which is also collapsed due to the same reason. So whatever the incident happened in the history in the past, the engineer should be aware of those incidents, so that the same incident might not happen in our projects. So this is nothing but learning from the past. Comparison with standard experiments. Engineering is different from standard experiments. Experimental flow. In standard experiments, two types of groups will be present: specially treated groups, control groups. In engineering, no control groups will be present, because here the clients will be having more control. Engineering experiment does not provide much knowledge, but scientific experiments do. There is one thing called informed consent. Engineering products are going to be used by human beings. So engineering products have strong human interface in the use of engineering experiments results. When testing on a person, he should be informed with all potential dangers of that particular product. For example, you might have noticed the ingredients present in the face cream at the back of the face cream cover. So, if it is danger, or the disadvantages also mentioned in that face cream pack itself. So prolonged usage is unavoidable, shouldn't be used reaching your eyes or mouth like that. Okay, so informed consent is an important factor. Whatever the thing it's going to happen, it should be informed to the general public who are using those products. The consent should be voluntary rather than any force. All the information provided should be consent. The consenter should be competent enough to process the information and to make the decisions. Informed consent is understood by two ways. Knowledge based, the human subjects must be provided with all information to make reasonable decision. Voluntariness is, the human subject should show their willingness to be human model voluntarily. Provide compensation for any harmful effects of that experiment. So with this, we stop here with the first topic of third unit. It's about engineering as social experimentation. So normal experiment which we do in laboratory is different from the engineers who do lots of projects. Normal experiments can cause less harm, but engineering projects causes many losses if it is done in a unawareness form. So you have to learn from past, we have to know the knowledge of the product, you have to be very precautionary, and if it does any harm to the individuals, it should be informed to the individuals as informed consent. Okay, thank you students, we will meet in next lecture.